So let us summarize some of the equations that we have derived so far. So we will divide this into two sets of equations. One set is for u greater than 0 and less than or equal to 60 degrees. The other set is for u greater than or equal to 60 degrees and less than 120 degrees. So we got a few equations for u greater than 0 and less than or equal to 60 degrees. So I'll write all these equations. The first equation is relating VD, VDO, alpha and u. So VD is equal to VDO by 2 cos alpha plus cos alpha plus ID is equal to IS cos alpha minus cos alpha plus. Then we also got an equation relating VD, VDO, gamma and u. So we have VD is equal to VDO by 2 minus cos gamma minus cos gamma plus. Similarly, there is an equation relating ID, IS, gamma and u. So ID is IS into cos gamma minus cos gamma plus. And there is an equation relating VD, VDO, alpha, RC and ID. So we got VD is equal to VDO cos alpha minus RC ID. And the last equation that we consider now is the relation between VD, VDO, gamma, RC ID. So that is VD is equal to minus VDO cos gamma plus RC ID. So these 6 equations were obtained for u greater than 0 and less than 60 degrees. We got similar equations for u greater than or equal to 60 degrees and less than 120 degrees. So let me summarize those equations. 60 degrees less than or equal to u less than 120 degrees. So VD is equal to root 3 VDO by 2 cos alpha minus 30 degrees plus cos alpha plus u plus 30 degrees. Then the equation relating ID, IS, alpha and u is ID is equal to IS by root 3 into cos alpha minus 30 degrees minus cos alpha plus u plus 30 degrees. VD is equal to root 3 VDO by 2 minus cos gamma minus 30 degrees minus cos gamma plus u plus 30 degrees. And the relation between ID, IS, gamma and u for 3 and 4 valve conduction mode, or of course even 3 valve conduction mode, is ID equal to IS by root 3 cos gamma minus 30 degrees minus cos gamma plus u plus 30 degrees. Then we have two more equations involving RC. So VD is root 3 VDO cos alpha minus 30 degrees minus 3 RCI, and VD is equal to minus root 3 VDO cos gamma minus 30 degrees plus 3 RCI. So I have 6 equations for 3 and 4 valve conduction mode and 3 valve conduction mode, and 6 equations which is applicable for 2 and 3 valve conduction mode as well as 3 valve conduction mode, because both these sets of equations are valid for U equal to 60 degrees. Now we are all familiar with what is known as normalization. Normalization is something which is very common in power system analysis. So it will help in simplifying the equations. So let us see how we normalize the equations which are applicable to the converter. Of course, we will consider only the quantities on the DC side. So we need to find what are the suitable base values. So if I take the DC side voltage or the DC side current, then I need to find the appropriate base value. So I get a normalized value or the quantity in per unit by dividing the quantity by the base value. So if I take the DC side voltage VD, the average value of the DC side voltage VD. So we choose the base value as VDO. So I normalize the DC side voltage by dividing it by VDO to get what is known as the VD in per unit. So I differentiate between the actual VD and the VD in per unit by a bar. So VD bar is the DC side voltage in per unit, which is defined as the actual VD divided by the base value VD. Similarly, if I take the current ID, the normalized current or the current in per unit on the DC side is defined as the actual current divided by the base value. So here we choose the base value as 2Is. If you look at the expression for VDO and IS, VDO is 3 root 2 by pi V, where V is the RMS value of line to line voltage, and IS is V by root 2 omega OL. Omega O is the operating value of the angular frequency and L is the inductance in each phase on the AC side. So if I assume V, omega O and L to be constant, so let V, omega O and L be constants. So it actually means VDO and IS are constants, then VDO and IS are constants. So there are other quantities which may vary. There are the other quantities. So what are the other quantities? The other quantities are VD, ID, alpha, U, gamma, may vary. So what we will do is we will try to rewrite the equations that we wrote just now in terms of the quantities in per unit. So I have VD and ID in the equations that I have written just now. So I will normalize these equations and try to write these equations in terms of VD bar or ID bar, which are nothing but the voltage and current in per unit. So if I look at these equations, I get the equations in per unit either by dividing it by VDO, which is the base value of VD, or dividing it by 2Is, which is the base value of the current. So if you look at this set of equations for U greater than 0 and less than or equal to 60 degrees, I have 6 equations. So the first equation has to be divided by VDO, because all the quantities in this equation are voltage. The second equation, of course, all the quantities are current. So if I want the quantities in per unit, I have to divide the second equation by 2is. So let us try to do this normalization by taking one equation at a time. So if I take the first equation, so I divide both sides of this equation by VDO, then I get on the left hand side VD by VDO, which is nothing but VD bar. On the right hand side, VDO in the numerator gets cancelled by the VDO in the denominator. So I get on the right hand side 1 by 2 cos alpha plus cos alpha plus. So I can do the normalization of current also. So if I take the second equation, I divide the left and right hand sides by 2is. So id by 2is is nothing but id bar on the left hand side. So on the right hand side, I get 1 by 2 cos alpha minus cos alpha plus. So the third equation is VD bar equal to 1 by 2 minus cos gamma minus cos gamma plus. And the fourth equation is VD bar. Fourth equation is ID bar equal to 1 by 2 cos gamma minus cos gamma plus. Then the next equation is VD equal to VDO cos alpha minus RCID. So I have to divide this equation by VDO. The left hand side is VD bar. The right hand side is cos alpha minus. So the second term is RCID. If I divide this by VDO, so if I use the definition of RC, then the second term on the right hand side of this equation after normalization is ID bar. And the last equation is VD bar is equal to minus cos gamma plus ID bar. Now if you notice the equations that I have obtained from the original equations, so there is no VDO, there is no IS. So what I have on the revised set of equations is VD bar, ID bar, alpha and of course in some equations there is a gamma. Okay, so I don't have VDO anywhere after normalization. I don't have IS. I don't have even RC. Okay. So I can similarly get the equations in per unit for this set of equations, which is applicable for u greater than or equal to 60 degrees and less than 120 degrees. So the first equation is normalized by dividing by VDO. So the left hand side is VD bar is equal to root 3 by 2 cos alpha minus 30 degrees plus cos alpha plus u plus 30 degrees. Then the second equation is normalized by dividing by 2is. So I get ID bar equal to 1 by 2 root 3 cos alpha minus 30 degrees minus cos alpha plus u plus 30 degrees. Then the next equation is divided by VD on both sides. So I get on the left hand side VD bar. So this is equal to root 3 by 2 minus cos gamma minus 30 degrees minus cos gamma plus u plus 30 degrees. The next equation is divided by 2is. I get ID bar is equal to 1 by 2 root 3 cos gamma minus 30 degrees minus cos gamma plus u plus 30 degrees. The next equation, I have VD, VDO, alpha, RCID. So after normalization, I will not have VDO, I will not have RC. So I get VD bar equal to root 3 cos alpha minus 30 degrees. So if I use the definition of RC, so RC is defined as VDO by 2IS. So I get the second term on the right hand side of this equation as 3ID, 3ID bar. And the last equation is obtained by dividing both sides by VDO. I get VD bar equal to minus root 3 cos gamma minus 30 degrees plus 3ID. 3ID. So what we have done is obtained the equations in per unit VD, per unit ID instead of the actual VD and actual ID.
So there are 7 quantities. So let me write down what are the quantities. There are 7 quantities. The VD or VD bar, which is the VD in per unit, ID bar is nothing but ID in per unit, alpha, U, gamma, beta and psi. So there are 5 angles and the voltage VD bar, the current ID bar. So among these 7, if 2 of these quantities are given, the remaining 5 can be determined. So if 2 of these quantities are given, the remaining 5 quantities can be determined. So we can use the different equations that we have derived to derive the values of these 5 quantities from the given values of 2 quantities.